Hello, my dear friends. So, this was all about multiple integration that we saw in this lecture series. So, let's summarize whatever I have taught you in these last 10 lectures. So, to begin with, we started with my lecture that is, what do you mean by multiple integration? We saw what do you mean by double integration, then what do you mean by triple integration. So in this chapter, basically, when we studied integration, we have studied two things, that is double integration and then triple integration. So again in double integration, we saw things like, first we saw the sums where the limits were given. In the limits were given, we decided that with what to integrate first, whether to integrate with x first or y first, or whether to integrate with y first or x first. If the innermost limits were in form of x, then we integrated with y first, the opposite variable, and outer limits are obviously constant. Similarly, if the innermost variable are in form of y, we integrated with x first and the outer limit with y. Next type we saw where the limits of integrations are not provided. So if limits are integration are not given, we have to find the limits. How did we found the limits? We drew the curves first, whatever curves were there that we drew. For that, I have seen some standard curves. We draw those curves, we find the area of intersection. After you find the area of intersection, we will be taking either a strip which is parallel to x-axis, okay, or a strip which is parallel to y-axis. So if that is your choice, basically what strip to take. If I take a strip parallel to x-axis, I will integrate with respect to x first, okay, and my inner limits, will be x is equal to some function of y, right, and outer limits will be constant. If you take a strip parallel to y-axis, you integrate with y first, okay, and now my inner limits will be y is equal to something, and obviously outer limits will be constants, right? If you take a strip parallel to x-axis, that is a sleeping strip, then it will travel from down to up, and the limits will be lower end and left end and right end. If you take a strip parallel to y-axis, that is a standing strip, the strip will travel from left to right, and the limits which touches down is your lower limit and which touches up is your upper limit. So this is what we saw when the limits of integration were not provided, right? Next we saw change of order sums. Change of order means, in example, they will be giving the limits and then you have to decide with what you need to integrate, right? So if in the example they have integrated with x first, that means they have taken the strip parallel to x-axis, then in change of order, you will reverse the order. That means you will take a strip parallel to y-axis and integrate with y first. Usually, change of order is necessary so that my integration becomes more simpler and more easier, right? We saw the sums of polar form of double integral. So polar form double integration can be solved in polar form also. Polar form in the sense, here in polar form, we substituted x is equal to r cos theta, y is equal to r sin theta, and dx dy as r dr d theta. We also, in that lecture, we also saw some standard curves like a complete circle, a semicircle, a cardioid, a lemniscate, etc. And we saw the standard limits just to take the idea how to find the limits of the polar form. In the polar form, I don't have a vertical strip or a horizontal strip. I have a radial strip which travels in anti-clockwise direction. Like suppose if this is a strip and this is a point, it will travel in anti-clockwise direction, that is this way, right? Innermost limits are in form of r and outer limits are in form of theta. So this was your polar form. We also saw how to find the limits of the polar form. So this was what we studied in double integration. In triple integration, basically what we studied first is what do you mean by triple integration? Next, in triple integration, again we saw two types of sum if limits are given, right? If limits were given in the triple integration, that means you should always look in the innermost limits. If the innermost limits are in terms of xy, that means integrate with respect to z first. If z is done and in the middle limits are in terms of y, you integrate with x, and then these will be some constants, you integrate with y. So it's not always dx dy dz or dz dy dx. It totally depends on your limits. So always check the limits when you solve the triple integration. Next type we solve in triple integration if limits are not given. If limits were not given, then we found out the limits. How did we find out the limits? I had given some standard spherical polar coordinates and cylindrical polar coordinates. So this was for a complete sphere, a hemisphere, for a positive octant of a sphere, for a tetrahedron. Some standard limits we have already seen. So if such sums comes whose standard limits you know, you can directly write the limits of r, theta and phi. So in this will be r, this will be theta, this will be phi in my spherical polar coordinates, right? But what if a standard limit is not given? That means if a paraboloid is given or a cone is given or something like that, whose limits you don't know and you need to find out. What if a standard curve is not given? So I have given you a shortcut way. Instead of learning the cylindrical coordinates and spherical polar coordinates, there is always a way out. For innermost limits, first you find the limits of z of Cartesian form, integrate with respect to z first, right? And now this double integration, you will convert this into polar form and then solve this as how you solve your double integration polar form, right? So this was sums we took on triple integration. The last two lectures that we are studying is applications of your multiple integration. So first application we studied was area. Area formula is, for my Cartesian it is double integration of dx dy, and for my polar it is double integration of r dr d theta. So depends on what sum is given, you will find the area. So finding area is just as finding the double integration whose limits are not given. So the concept is nothing new. I have taken enough sums in the lecture. So even if you write down those sums in your notebook, you are through. Next we saw was your volume. Volume is a application of triple integration, and the volume formula that we saw was dx dy dz, and triple integration, if it is a spherical polar coordinate, it is r square sine theta dr d theta d phi. And we saw the sums on volume as well. So we have covered all the types which are there in your syllabus. I just hope that you have understood. Just practice more and more sums, and whatever sums I have taken in the video, try to solve those. Okay, so solving is a key to success in mathematics. I just hope you will do well in the exam. All the best for your success.